Alright, this is my first time trying a video like this, so y'all don't judge it too harshly. If you want to, go ahead and pause and look at the notes at the top of the screen right now. Basically, you're just gonna try to solve this as if this little cosine x thing right here, just pretend like it's an x for right now. So if you had like 2x plus 1, then the first step you would want to do is go ahead and subtract 1 to the other side. And so then you would have 2x, which is actually cosine x, equals 2 minus 1 is 1. And so now you're going to have, basically, in your head, think of it as 2x equals 1. And so if you had 2x equals 1, the way you would solve it is you would divide by 2. So now you have x, or in reality, cosine x, equals 1/2. And so then I have up here, if you actually paused it and read this, you're going to want to use the unit circle to find any solutions between 0 and 2 pi. So if you want to have a unit circle out while you're doing this, that might be helpful. I'm just going to come up here to this one. Remember, I know it's been a while, on the unit circle, x is cosine, y is sine. So what we needed was for cosine of x to equal 1/2. So we're going to look for x values of 1/2, and we have it at pi over 3 and 5 pi over 3. So we're going to come back over here. We know now this works, where x is pi over 3, and that's an and sign, 5 pi over 3. And that would be our answer. Okay, here's another example like you guys would probably be more familiar with. In this one, we want to go ahead and get all of the variables, which in this case are both sine of x, and all of the constants, which is the square root of 2, on opposite sides technically. We want the variables on one side and the constants on the other. So the first thing I would do is add my sine x to this side. And I'm going to subtract the square root of 2 to the other side. So now on this side I would have sine x plus sine x, which is going to be 2 sine x. And on the other side, I got rid of my negative sine x over there, so now all I have is negative square root of 2. And so then at that point, we just need to divide by the 2 in the front of the sine x. And we would get, that would cancel. And sine x equals negative square root of 2 over 2. So like I said, you're just going to go back to the unit circle, and we need sine, which is the y value, to equal negative square root of 2 over 2. So we have that down here and down here. And so we know that our answers should be 5 pi over 4 and 7 pi over 4. So I'm just going to come back over here, and x equals 5 pi over 4 and 7 pi over 4. Alright, so this one's going to be slightly different, maybe a little bit new for you guys, just because it has a sine squared x in it instead of just a sine x. So sine squared x is really, it's sine x, but it's squared. It's nothing more complicated than that or anything like that. So again, my suggestion would just be look at the sine squared x as if it's like an x squared. So if you have 4x squared equals 1, the first thing you would do is divide by 4 on both sides. So then you're going to have sine squared x equals 1/4. So now that looks weird, but if you imagine sine squared x is just x squared, then you would have x squared equals 1/4. So if you had x squared equals 1/4, you would go ahead and take the square root on both sides. And so that's the same thing we're going to do here. We need the square root of sine squared x and the square root of 1/4. So the square root of sine squared x is just going to be sine x, because that's just sine x squared. And then the square root of 1/4, if you need to use a calculator, go ahead and do it, but it's 1/2. So now we have sine x equals 1/2. I'll come back to the unit circle as always, and look for where y is 1/2, and that's going to happen at pi over 6 and 5 pi over 6. So I will come back, And no, x is just 5 pi over 6 and pi over 6. Okay, so if you're following along well so far, then keep watching because this is going to be fun. And if you're already a little bit freaked out, now's a good time to pause it and take a couple deep breaths, and then we'll continue. So, what we're looking at now is the quadratic form of trig equations. So that means we have a sine squared x minus a sine x minus a 1. So basically in the quadratic form, you're always going to have the trig function squared and the trig function by itself. But if you, instead of thinking of it as a trig function, just think of the sine squared x as x squared and sine x as x, then we can solve it like a regular quadratic equation, which you already know how to solve. You just factor it and then set the two factors equal to 0, which is what we're going to do here. So instead of 2 sine squared x, we're going to look at it as 2 x squared minus just a plain x and then minus 1. So then you're going to need to factor that. I've always done the slide and divide method in class. I'm not going to stop now. So I'm going to slide that 2 over and have x squared minus x minus 2 because I multiplied the 2 by the 1. Now I'm going to factor that. So I have x squared minus x minus 2. That's going to factor to x minus 2 times x plus 1. But since I slid the 2 over, I need to now divide the 2 back out. So I have x minus 2 over 2 is x minus 1. And x plus 1/2, I want to just slide that 2 back to the front so I don't have a fraction in my factor. So I have 2x plus 1. So now I need all of this to come back over here and apply it with sine x instead of x. So that means I'm going to have sine x minus 1 times 2 sine x plus 1. And then now I just want to set each of those factors equal to 0. So I have sine x minus 1 equals 0 and 2 sine x plus 1 equals 0. And then we're just going to solve them the same way that we've been solving all the others. So on this one, I'm going to add 1 and I'm going to get sine x equal to 1. I'm going to come back to my unit circle. I look for where sine is 1. Sine is the y value, so I just need the y value to be 1. That only happens right here at pi over 2. So I come back down here, and one of my solutions is x equals pi over 2. But we're not done yet because we still have that other factor to consider. So the first thing I'm going to do is subtract 1. And I have 2 sine x equals negative 1. Now I need to divide by 2 on both sides. And I have sine x equals negative 1/2. And so again, just go back to the unit circle. We need our y value to be negative 1/2. So that happens. I can't get this thing out of the way, guys. I don't know what's happening. There we go. Okay, so that happens down here at 7 pi over 6 and again at 11 pi over 6. So I'll come back here and I have x equals 7 pi over 6 and 11 pi over 6. And now all three of these are going to be solutions to this equation. Okay, so now is a good time to go ahead and pause again and look at what we have written at the top of the screen. So the big thing that I want you to notice here is that we have sine x squared, but then we have cosine x. So we can't really do anything with factoring with those two since we don't have the same trig function. So what we have to do is rewrite the equation so that it only has cosine functions. So it's not always going to tell you which one that you need to rewrite it in the form of and stuff like that. Basically, there's not much you can do to change this cosine into sine. However, when you have sine squared x, we have this handy trig identity here that says sine squared x plus cosine squared x equals 1. So that means there is a way to alter the trig identity to make that sine squared x turn into a cosine squared x, and then we'll have all cosines. So basically what we want to do is solve in terms of sine squared x so that we can replace it in the equation. So I'm going to subtract this cosine squared x over to the other side. And now I have sine squared x equals 1 minus cosine squared x. So now in our equation, and I'm going to come to the next slide here, we know sine squared x equals 1 minus cosine squared x. So I'm going to replace this sine squared x with 1 minus cosine squared x. And then I have plus 3 cosine x minus 3. And it all equals 0. So the first thing that I need to do now is go ahead and distribute that 2. So I'm going to have 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. So now we have two constants in here. And so I'm going to combine my two constants. I have a negative 3 and a 2. That's going to be a negative 1. So I have negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. And now we need to factor. So my tip for whenever you need to factor something that has a negative in the front, I don't really like to deal with that whenever I'm trying to factor. So I just divide by the negative. So whenever you're dividing by a negative, what you're doing is essentially just changing the sign of every single thing in that equation. So my negative 2 cosine squared x becomes positive 2 cosine squared x minus 3 cosine x plus 1 equals 0. We're not really going to make it positive or negative, so it's just going to remain 0. So now we need to factor 2 cosine squared x minus 3 cosine x plus 1. So if you want to just write it out as 2x squared minus 3x plus 1, then you can. If you'd rather just go ahead and use it in the cosine form, that's totally fine too. So now we need to factor 2x squared minus 3x plus 1. So I'm going to slide my 2 to the end, and I would have x squared minus 3x plus 2. Then I need to factor that, so that's going to factor into x minus 2 times x minus 1. And so I'm going to then go ahead and divide my 2 back out that I had multiplied by originally, and I would get x minus 1 and 2x minus 1. And now I'm going to bring it back over here as my factors for this cosine squared x equation. So I would have cosine x minus 1 times 2 cosine x minus 1. Now I'm going to set both of these equal to 0. So cosine x minus 1 equals 0, and 2 cosine x minus 1 equals 0. Now on this one, I'm going to add the 1 to both sides, and cosine x equals 1. I will come back to my unit circle. Cosine equals 1 when x is 0, or 2 pi if you want to throw that in there too. They would both technically be solutions. So x equals 0 or 2 pi. And now I'm going to go to my other factor and add 1. So I have 2 cosine x equals 1. Divide by 2. And I have cosine x equals 1/2. And I'm going to come to my unit circle to find where cosine equals 1/2, which happens at pi over 3. And again at 5 pi over 3. So now I have x equals pi over 3 and 5 pi over 3. And in this one, all 4 of these are solutions. So now we've done a couple of examples of pretty much every way that you'll see these trig functions that you need to solve. I did put it back on this slide because I want you to notice in that last example, we used this trig identity. However, you could be using either one of the other two as well. So like if you notice that an equation had tan squared, but then it just had regular secant x, then you would have to rewrite it so that it would only have secant squared, because you can't solve it if it has two different types of trig functions in it. So just be really careful with that. I'll definitely post some more examples for you guys to work on. And if you have any questions, please don't hesitate to join the Google Meet thing during office hours. If I need to post some more office hours this week or next week, I definitely will. Just let me know. Also, text me through Remind if you have any questions, and I will literally jot down some stuff and send you a picture back if I need to, or email me any way that you need to contact me whatsoever. Please don't hesitate to do so. I'm available pretty much all the time. I'm just sitting at my house, just like you guys are. So please contact me if you have any questions. Hopefully this video helped with understanding solving trig equations a little bit better. And I guess that's about it. I hope you guys are staying safe, staying home, and staying healthy. And I really, really hope that I'll see you back in school after May 15th. But bye for now.